So now the biggest question is, this is just one replica. Only one replica, isn't it? What happens to the rest? We talked about replication factor equals 1 is not necessarily a good thing. It needs to be greater than 1, right? So, and for discussion's sake, we've said, okay, fine, it's not going to be 1. Replication factor in real life is going to be 3. And I know, I did mention that I'm going to talk about the scientific way of determining why 3. That's going to come to it a little bit later. But before I go to replication, you might be wondering, oh, wait a minute, you just explained the token distribution with just 100 tokens. Is that all that Cassandra can handle? Not really. 3 things that we must know. This hashing algorithm is called Murmur-3 hash. It was created by Austin Appleby in 2008. And one of the unique things about this hash is it generates very, very wide token, right, for similar looking partition keys, or rather, values that you're going to give for hashing. For example, ABC 1, 2, 3. Suppose I have ABC 1, 2, 4. Very similar looking incoming data, isn't it? Murmur-3 hash is going to generate tokens which is very widely spread apart. Meaning, suppose this was generating 32, there's a good chance that this will not generate anything close to 32. It will be very far out, an advantage. Further, the Murmur-3 hashing algorithm's return data type is long. Yeah, let me continue with blue because that's all Cassandra. Long. Not the English long, this is the Java long. Right? This is not the English long, this is the Java long. And this range is negative 2 raised to 63 to positive 2 raised to 63 minus 1. So what I'm going to do is I'm going to call this as the range of long, or ROL. This is a huge number. So what basically happens is the demonstration that I did here with 100 tokens, in real life, in Cassandra, it is this range. 1 through 100 tokens was the range of long for this discussion. This is the actual range of long. I intentionally did not take this large number because this explanation would have become very complex. Well, actually, I wouldn't, remember how to divide this by 4 anyways. So what we're going to do is, let's not worry about that. But this is range of long. Yeah. Now you might wonder, what happens if we run out of range of long? Right? Just to let you know, I'm going to do a quick Google search to show you how big that number is. And then you'll realize, oh yeah. Okay, it's supposed to show here. Right, there you go. So negative 2 raised to 63 to positive 2 raised to 63 minus 1. And let's say long max value. Yep, there you go. That's the minimum and that's the maximum. This is a monster number. Just in case you want to do some analysis to find out, well, let's see, the current NTP, just trying to find out what my current NTP is. Oh, that's not nice. All right, I think there is one website which basically talks about the current NTP, and let me try and find that one out so that you will be able to see how large that number of Java long is, yeah, it's called currentmillies.com apparently. All right, so let me go there. Yeah, you see, this is the current milli at this particular point in time. So why don't I take, let's say, oh, well, why don't I take this, copy, and let me do an editor. And by the way, you do know what NTP is, right? It's the number of milliseconds that has elapsed from epoch. 1st Jan 1970. And I take this positive number and I paste it in here. Obviously, you might wonder, well, spaces. Okay, I'm going to, sorry, commas. I'm going to get rid of that. Check this out. So this is the number of milliseconds elapsed from epoch. That's a lot of milliseconds. And this is the number that Java long can deal with. And by the way, this is only the positive. There is an equal negative as well. So you can imagine this is a monstrous token range. So I don't want us to worry about what happens if I run out of tokens. That's not going to happen. All right, that was the purpose of this demonstration. Okay, so what we're basically saying is that we have a very large token range, and if I have a single node, the entire range of long will belong to this one node, and if I have multiple, it will be divided proportionately. Now the point is, whether I want to have large contiguous token range or smaller token ranges, that is left up to the system to decide. What do I mean by that? I'm going to introduce two subtopics under token: node and vnode. All right, what I mean by that? So what I'm basically saying is that if you are looking at a token distribution, for example, that I'm not going to bother about, the peers. Well, I'm going to, let's say, get another color in place. I'm not going to bother about, this, at least as of now. Okay. I'm going to talk about only this. Look at that. 1 to 25, 26 to 50, 51 to 75, and 76 to 100. Okay. So what is happening is this is a large contiguous token range. Now in 100, it might not appear to be so, but imagine if you took a 1/4 slice of this monstrous number, that's going to be a lot of numbers that is contiguous to each other, isn't it? So what basically happens is that's not a very good way to manage things. So what Cassandra will do is it's going to ask you another question. You remember the configuration file where you specified seed list? In there, it's going to basically ask you that, hey, instead of having such a large number, do you want me to chop it down into smaller numbers so that you can manage it well? Do you want some smaller segments, maybe 8? So for example, instead of generating one large contiguous token range, I'm going to generate 8 smaller token ranges, which is not contiguous to each other. Now allow me to illustrate. For instance, if I say that, look, my token range cannot exceed 5, so what will I get? I'm going to get a token range that looks like this: 1 to 5, 5 to 10, 11 to 15, 16 to 20. Am I done with token distribution? Nope. Do I need to go around the cluster the second time? Yes. 21 to 25, 26 to, 30, 31 to 35, 36 to 40. And am I done with the token distribution? Nope. Do I have to go around the cluster again? Absolutely. So I keep doing this. So what has happened? Instead of a large token range 1 to 25, I now have smaller token ranges, which is not contiguous, as you can clearly see in front of you. Are you getting this? This first strategy of large contiguous token range is called nodes. The second strategy, where you have multiple non-contiguous token ranges, there's a second strategy. This is called as vnodes. You know what is a VM, right? You have a physical host. You make multiple virtual machines from it. And then what happens? Each of those virtual machines acts as a node. We basically call it virtual machines. So here what is happening is you have a single node, and because of these many number of token ranges, it appears as though I have virtual nodes. It's just a fancy thing that we need to keep in mind, nothing else.